What's going on, everybody? My name is Michael Levan. Thank you so much for joining me today for part 5 and the last part of the Development for Infrastructure series. In this part, we're going to dive into continuous integration and continuous delivery, or CICD. And what we're going to be doing is we're going to be creating a full production level virtual network with a DDoS plan, security groups, subnets, all of that stuff using Terraform in Azure. So what is CICD and kind of, what does this mean? Let's go ahead and dive into a little bit of theory. Promise it won't take up too much of your time. So the first thing is, let's actually go over what CICD is. Continuous integration. Essentially, you get to build and test code by merging all of the code in a shared streamline. So for example, let's say you're working in GitHub and there's 5 infrastructure developers on your team. You guys may be working with, multiple different portions of a terraform configuration. You might be creating a virtual network, or you might be creating an entire piece of infrastructure. The point is, all of you are working on code at the same time, and you're also working on different code. So what CI allows you to do is you can actually take that code, commit it, push it to GitHub, and then have that code automatically build to ensure it actually works properly. The other thing that you can do too is you can build an artifact out of that code, and then you can use that artifact later for deployments. The second is continuous delivery. So a lot of people say continuous delivery and continuous deployment kind of like almost like it means the same thing, but it actually doesn't. It's extremely different. So continuous delivery automatically deploys code, but it's with human intervention. So for example, let's say you're using a pipeline like in Azure DevOps or in Jenkins or GitHub Actions or something like that. And then you go in and there's always some button that you can click to deploy it, a run button or a push button or something like that. When you do that, you are automatically deploying code, but you're doing it with human intervention. Somebody is physically logging in and kicking off that code. Now, when you come to continuous deployment, that means the code is automatically being deployed with no human intervention. So as soon as you commit, your CI process kicks off, the code builds, it tests, it makes sure everything works properly, and then it also deploys. And that could even happen in the same pipeline with multiple different stages. So you could have a build stage and you could have a deploy stage. So there's zero human intervention. As soon as you commit that code, it builds, tests, and pushes. So there's this huge question here that I kind of wanted to bring up in the CI/CD portion of to automate or not to automate. And it's funny, I used to look at this meme and laugh, and then I would look at this meme and be like, no, you can't really automate everything. And then now I'm starting to look at this meme as, well, it doesn't really mean like automate everything because, for example, if you're building a pipeline, a YAML pipeline, for example, to build and deploy your code, you got to write that code. You're not automatically just pressing a button and that code automatically gets written for you. When we talk about automation, especially from a DevOps perspective, it gets software into the hands of your customers quickly, efficiently, and much faster than doing things manually. Not only that, but you can automatically test, you can automatically build, you can automatically create artifacts, binaries. You could do a bunch of stuff in your code from a CI/CD automation process. The other huge thing here is, and this is probably one of the most important things, because you got to understand something, DevOps, being able to continuously deploy value to your end users, that's a business role. You are an engineer and you're writing code and stuff, but it's very much a business role because the whole thing about CI/CD is you want to stay ahead of your competition. You want to get that code out and that software out faster than everybody else, but you want to make sure that you do it in an efficient manner. So with that, let's jump into the demo. Before jumping into the CI/CD process, we need to have some code to deploy. So let's take a look at this Terraform code really quick. Now, I'm not going to go over what Terraform is or anything like that. I'm just going to go over quickly what this code is doing. So the first thing is we have this resource here to create a resource group, and we're creating a resource group to store the virtual network in. Next, we're creating a security group for the virtual network. We're creating a DDoS plan for the network. We're creating the virtual network itself. We're adding that DDoS plan to the virtual network. We have 3 subnets that we're creating. And then finally, we have a tag here that's set to production. We can go through, we can see that we have some variables here, so you can pass in the resource group name, the location, the security group name, and the VNet name. And then I have some pre-filled values here, so these arguments will be passed in at runtime. So with that, let's head over to GitHub and actually set up our first GitHub action. So I have GitHub open and I'm in my development for infrastructure repository. So that code that I just showed you, and you're going to be able to find it here in part 5 under VNet. You're going to have to take that code and you're going to have to put it into a repository. So once that code is in the repository, you're going to go to actions. And I already have a few actions set up here, so your screen's not going to look like this. But if I click on new workflow, this is what yours should look like now. So I'm going to click on set up this workflow. And what set up this workflow does is it kind of gives you this like boilerplate code where it just literally just echoes out hello world. Let's just go ahead and get rid of all of this. And what I'm going to do is I'm going to open up VS Code really quick. You're not going to be able to see it, but I'm going to copy and paste in the pipeline. And if you're curious what this pipeline looks like, it's under the part 5, and then you're going to see a github-actions.yaml. This is the actual pipeline itself. So let's go through this. First, you set up a name here, and the name you can name it whatever you want. I actually oops, gotta put a space there. And then on. So what on means is you have a few different ways that you can kick off pipelines. You can kick them off from the delivery method, or you can kick them off from the deployment method. So for example, let's say you want to do continuous delivery and you just want to have a button. Well, in that case, you would have like a manual deployment almost where you would come in here and you would kick off the CICD pipeline. In this case, we're doing a continuous deployment where we have push and then the branch is at main and then the pull request and the branch is at main. What this means is anytime that code gets pushed to the master branch, or if it gets pushed to, I'm sorry, not the master branch, the main branch, or if it gets a PR or something like that to the main branch, that means the code is going to be kicked off. So this right here defines how the code is kicked off. And then you have a job here, and the jobs, essentially what this does is this is kind of like what the pipeline is doing, you know, its job literally. So what it's doing is it's building and deploying. So I named it build and deploy, and then runs on. So pretty much every CI/CD platform out there has some sort of workers that are running in the background, virtual workers. And these virtual workers, they're sometimes Ubuntu or any Linux distro, Windows, Mac OS. In this case, we're using Ubuntu. So this machine here, I'm not maintaining it or anything like that. It's literally this Ubuntu latest. It's a container that gets spun up. It runs my pipeline and then it dies. So now we're going to have some environment variables. So the reason why we have these is because we need to authenticate from GitHub to Azure. Now you may be wondering, because I can actually show you this, there is an Azure login task here, which you can use to log in. But for the Terraform task to run Terraform code, or like Terraform init, Terraform plan, apply, you need to use like a user almost. It can't be, you know, just a service principal. It has to be a user. So that's why we're passing in this information here. So I'm passing in my client ID, the subscription ID, and the tenant ID in plain text. And then I have this secret here. So what does this mean? Well, I'm going to open up new window here, and under settings, I'm going to go to secrets. And under secrets is where you can actually create your own secrets. So I have this secret here called client secret. You can literally just new secret, name it, and then here you can put the value of that client secret. And you may be wondering at this point, well, how do you actually create those client secrets? How do you create a client ID without, you know, kind of jumping in and doing it manually? Well, what you can use is you can use this command, and this command will create a full service principal for you. And then you can use the tenant ID and the client secret and stuff like that. The steps. So the steps are, you know, think of these like functions, or think of these like literally like a step by step. Like, you know, if you have 3 tasks that you have to do today, you got to go to the grocery store, you got to do a little bit of work, then you got to take the kids out somewhere. Those would be your steps: grocery store, work, take kids out. Same thing here. So the first step is you got to check out the repository, you got to check out the code. So the code is in the Ubuntu latest container. Next, you're going to have to install Terraform, because Terraform is not installed on the containers or those GitHub runners by default. Next, you're going to have Terraform init, Terraform plan, and Terraform apply. And what I'm doing is I'm CDing or changing the directory into where exactly the code lives. So on the container, on that Ubuntu latest, it lives in home, runner, work, and then the repository. So development for infrastructure, part 5 VNet. And you can see, like, for example, that's my repository name here. And then once you change directories there, it has a Terraform init, Terraform plan, and Terraform apply. This right here means end. So do this end do the terraform init, cd into this directory, and do the terraform plan. And then for the terraform apply, we have an auto approve because, there's no Y switch, minus Y, so you could just like kind of force it or anything like that. So with that, let's go ahead and actually kick off our pipeline. Let's build our resource group and our virtual network. So I'm going to click on start commit, and then right here we can just leave all of this default. It's going to commit directly to the main branch. The reason why is because the code is in the main branch. So we're going to commit new file. And then at this point, if you click on actions, I'm going to open up a new tab here, we can see that this new action is officially kicking off. So we can click on this. Under jobs, we can go to build and deploy, and then we can actually watch our pipeline run. And we can see that this completed successfully. So let's actually go through these steps. The first is the code, and as you can see, it's putting the code under this home runner work directory. And it's installing Terraform for us, so it's installing the latest 0.14.4. Wow, I didn't even know 0.14 was out. And then under Terraform init, it's initializing that repository. We have the plan going through here, making sure that everything looks good. And then finally, we have that apply where it creates the resource for us. So if I open up the Azure portal and I refresh, here's our new resource group. And here's our resources. And that's how you can automatically deploy your infrastructure code using CICD. Thank you so much for watching, and especially thank you so much for watching this series. We'll see you again next time.